So we're going to keep going here in section 6.3. And again, I'm given directions. Find values for theta that make this true, which means basically I want to get theta alone. Theta equals something. Okay, and where it's located, I know it's going to be angle measures. Well, the first thing I need to do is say, okay, I'm going to do something like the cosine of 2 theta equals -1 over the square root of 2. And if I'm, I'm working with the cosine, and I know my magic numbers over here. Okay, and again, that goes way back to 45, 45, 90 was some of my magic numbers, and that was 1, 1, the square root of 2, and some other magic numbers with the 30, 30, 60, 90 was the 1, the square root of 3, and the 2. So when I was seeing those, they were these were always happy numbers for me. All right, Ethan threw up an answer. See where he's at with that. All right, so I know the cosine of 2 theta equals that. Now, if this was just theta, that would be great. Well, it's not. So what I'm going to do is, did anybody do this? We'll pick a W and let W equal 2 theta. Okay, I'm all right with that. Now I have the cosine of W equals -1 over the square root of 2. Ah, yeah, this is good. This is real good. And I'm going to work with W, and I'm going to say, okay, the cosine is negative. All spiders taste crunchy. All spiders taste. The cosine is negative over in quadrants 2, as well as quadrants 3. All right. How are we doing with that so far? Questions on that?
I have a question actually.
Go ahead.
So couldn't you just finish solving for cosine 2 theta by just the square root of 2 and moving it to the top, and then be square root 2 over 2?
Okay, yeah.
Solve from there.
I see what you're saying. This is also negative square root of 2 over 2, but I still can't do anything with the cosine of 2 theta. Because remember, again, my goal is to get the theta alone. So I need to get rid of that. And so I'm saying, okay, temporarily, I'm going to do a substitution. And substitutions are big. Because now I know how to do this. This was really close, but this is a little better.
Okay.
All right, so the cosine, here's -1, here's the square root of 2, and there's 1. So the cosine is adjacent over hypotenuse. And yes, this is in fact my 45, 45, 90 triangle. So right now I'm sitting at theta equals this angle. Okay, this is the reference angle for 180 minus 145, which is 135. Well, I need to back up because it's not theta. I'm going from here over. This is actually W. Okay. My other angle where this is true is down here in the 3rd quadrant. That's a -1 instead of a +1 going up. And this looks like it's going to be 180, 225. Okay. This was something we did some time ago, putting them on here. We came up with this building block so we can start to learn more things on top and on top. All right, so now I don't want W, I want theta. So I'm going to go 2 theta equals 135 degrees, 225 degrees. If I divide them by 2, I get theta equals half of that, 67.5. Half of this, 112.5. And it looks pretty good. But we did a problem the other day where I had this 2 theta, and I know I'm going to be dividing these angle measures by 2. I'm saying, well, wait a minute. I can go to this angle measure, which was my 135, but I could also go all the way around and do the next time around, because I'm going to be dividing it by 2, this 360 degrees plus 135, which is 395. When I divide that by 2, I get 197.5. I'm still in my range from 0 to 360. And just like I took the 135 and went around again, knowing I'm going to divide by 2, I'm going to take the 225 and add 360. That gives me 585. And again, as I divide it by 2, 292.5. That is also in my range between 0 and 360. Yeah, no. 4 answers. So I went around once, then I added 360 to go around again to each of those values because I knew I was going to be dividing by 2. What if this would have been 3 theta? Well, if that would have been 3 theta, I'd be dividing by 3 when I got down here. I not only would go around once, twice, but I would add another 360 to both of these. Because when I divide those by 3, I would absolutely be in my range from 0 to 360 degrees to start. Cool. If I look back, Jack, do it again. I see Chow had 45 divided by 2. She was getting some numbers and dividing by 2. She was on the right track. The 405 she had was 45 plus 360. Yeah, she was just in the wrong quadrants. She was working with being a positive instead of 2 negatives. Tomas.
Yeah, Professor. So if it would have been a 3, you would have added 720.
To these first 2. Yep.
Okay, thank you.
Yeah. Now, if you think about it, if I add 720 to this, I'd get 835. And if I divide 835 by 3, I'm definitely under 300. Yeah. Yep. I'd be under the 360 that I need. Cool. Gianni.
So how did you know when to add them again? Like the certain amount that Thomas just asked?
See this 2 theta?
Yeah.
I'm going to add another 360. If it was 3 theta, I would go around again. I would take this and add 360 and this and add 360. What he said is, could you have just added 720 to these? Yes. You add 360 to these. You add 720 to these. You went around again, you'd add 1,080. Lots of different answers.
Understood. Thank you.
Yep. I said, hey, oh boy. Last one in 6-3. Let's see what we have. I'm going to give you a hint. Should I give you a hint?
Yes, please.
Okay, here's the hint. Square both sides. Well, the reason I'm doing that is I'm looking at this. I know the tangent and the secant are related. How are they related? Because somewhere I have cosine plus sine equals 1. I have that written down. And I know if I divide all of these by cosine squared, that's 1. This divided by cosine squared is tangent squared. This divided by cos is secant squared. Back when we first learned these, I said, we're going to use this one most of the time. We'll use this one quite a bit as well, and here it is. So I'd like you to square both sides and go from there. Now, remember, I am squaring a binomial. It's not distributive. I am squaring a binomial. Okay, give that a couple minutes and see what you can do. Well, he said square both sides. So I'm going to go tangent squared of 3x. Outer, inner would give me plus 2 tangent of 3x, secant of 3x, plus secant squared of 3x equals 4. I don't know if I like that. I don't know if I like that. Why don't I like that? Well, I know I'm going to replace maybe like secant squared with 1 plus tangent, but I still have a secant in there. And these two guys were messed up. You know, they started on the same first side. When I squared it, I got something along those lines. Good try, really good thought, but I'm still stuck with a mixture, and I don't want a mixture. Any ideas? I still feel something squaring is going to help me out. Again, I could replace this, and make it 1 plus tangent and deal with that. And then, go ahead.
Would you take the square root of each side?
Square root of each side. It's good I have a big eraser. You meant from where we were or from the start? If I did it
From where we
where we
were.
were, well, if I did it where we were, it's going to bring me right back to here. I'm stuck there again. So that, so again, I'm thinking, I don't like the way that ended by squaring, but I know I'd like to get some of these squared. Anybody have another idea? I do. Pick me. Somebody pick me. What if I sent one of those over there? What if I said, okay, before I square it, I have the tangent of 3x. I'm not going to put plus, I'm going to put equals 2 minus the secant of 3x. I'm sorry, I keep getting my angle. 2 minus the secant of 3x. Now they're not going to be mixed up, are they? I sent that guy over, and so now I'm going to square this side. And I'm going to square this side. This guy's nice. Tangent squared of 3x equals 4 minus, again, I'm writing this as a binomial. This goes back to algebra. You know, you should have practiced and practiced. 4 minus 4 secant of 3x. And then plus, I don't need these anymore for right now, in a minute, plus secant squared of 3x. I like that. I like that. I like that that doesn't have a tangent with it anymore. All right, so far so good. Oh, I just erased it. What does the tangent squared equal? Well, I can vaguely see it. I see that it was 1 plus, yeah, tangent squared equaled secant squared. Okay, so now in place of the tangent squared, I'm gonna put secant squared minus 1. Secant squared of 3x minus 1 equals 4 minus 4 secant of 3x plus secant squared of 3x. I'm seeing polynomial here, a quadratic, a squared, a single one, and a number. And I'm going to say Red Rover, send all this stuff over. I'm going to add 1. That gives me 5. I'm going to subtract secant square. Oh, that's kind of nice too. And I'm going to have negative 4 secant of 3x equals 5. The secant squared's canceled. I added 1. Oh, that's a plus, not an equals. I had a 5 and I had a negative. Oh, geez. Goodness gracious. Huh. I'm gonna keep going. I'm gonna subtract 5 and divide by 4. Subtract 5, then divide by -4, excuse me. And I get the secant of 3x. Lots of little algebra. It's like a gigantic puzzle. All these things that we've learned over time and how we're reusing them with a new type of math. I'm gonna say, oh, if this is the secant, well, this is gonna be 5/4. I know that if I clean that up. This is gonna be the same as 1 over the cosecant of 3x. Okay, good. And I'm gonna do the reciprocal, and I'm gonna say the cosine, excuse me, of 3x equals 4/5. Now, 4/5, is that any of my good numbers, my special triangles?
I don't think so.
No. So this is actually going to be one where, I might say W equals 3x means I'm going around 3 times. I know that. So I'm going to say the cosine of W equals 4/5, things I know. I'm going to go up into this triangle here. I'm going to say it's in the, all spiders taste crunchy, all in the first and the fourth quadrants. First and the fourth quadrants. So this guy right here, and this is a big reminder, this guy has 2 answers, okay, in the first and in the fourth quadrant. And the way I solve that is I jump to this. W equals the inverse cosine of, I'm going to put 0.8 because I know I'm putting this in my calculator in a second. It's going to be, this guy only has 1 answer. Because remember, when I'm dealing with cosines, the positive is in the first quadrant, the negative was in the second quadrant. We go back a little bit to get some help with that. So this guy's going to give me 1 answer, but I'm going to use that to find the 2 answers here. Then I'm going to go around 3 times. What? So W equals, and let's see, I want the inverse cosine of 0.8, and I get 36.87. So W equals 36.87 degrees. That's in this first quadrant. The fourth quadrant is going to be 360 minus 36.87. Boom, is 323.13 degrees. So I found my first 2 answers. Now I know my W is going to go around 3 times. So when I substitute back with 3x, I need to go around 3 times. Oh boy. So now I'm going to have 3x in place of the W. I'm going to have 36.87. I'm going to have 323.13. I'm going to add 360 to this. 396.87. Oh my. I'm going to add 360 to this. 683.13. Oh, that's not it. 683.13. I'm now going to add 720 to this. 756.87. And I'm going to add 720 to this. 1043.13. Goodness gracious, there was a lot to this problem. Am I done? I am almost done. I need to divide each one of these by 3. So let's see. 36.87 divided by 3 equals x equals 12.29 degrees. Divide this by 323.13 divided, oh, not times, divided by 3, 107.71. Remember I added 360? Well, what if I just divided that by 120? Yeah, that's what I could do. So I could add 120, or divided it by 3, excuse me, I'd get 120. So I can just add 120 there. 132.29. That's the 396.87 divided by 3. This guy divided by 3, same as adding 120 onto this. 227.71 degrees. I'm running out of paper. This guy divided by 3, 252.29. And 1,043 yada 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 divided by 3, 347. Point, where am I? 71. Holy cannolis. Just like on the test, you're gonna, yep, you're gonna do something like that. Okay, any questions? Any questions? So 6.3 is now asleep. We're gonna do some at 6.4. We should be good to go. I want to start out with an equation, and I have y equals the 3 cosine of 2x. I just want to solve for x, okay? And this is gonna go back to something I talked about a minute ago. Solve for x, okay? I'm going to divide by 3. Y over 3 equals the cosine of 2x. I'm going to take the inverse cosine. Once again, my inverse cosine, that's a really bad y. The inverse cosine only gives me one answer. Where does that go back? What are you talking about? Remember when we were doing inverses and we said for the cosine, I needed to restrict the domain. I needed to restrict the domain. And here's the values from 0 to pi over 2. So if I go to my unit circle, 0 to pi over 2 is the first quadrant, which is the positives. And my other restriction went from pi over 2 to pi, and that was all of my negative values. So that was the second quadrant. Okay, here's all the positives in the first, all the negatives are in the second quadrant because I restricted this. So this, when I'm dealing with inverses, I only get an answer either in the first or the second inverses. And then finally, I would divide this by 2. So if the direction simply just said solve for x, that's what it would look like. All right, so now I'm coming down to this problem. I'm starting with the inverse cosine. Unlike that last problem I did over here, you know, I didn't start with it. I had to go through and say, what's the cosine right there? That's going to give me, when I'm dealing with inverses, a negative. But since I started with the cosine, it's going to be 2 answers. Here I'm starting, there's only going to be 1 answer. Okay, let's see what I have. I have the arc sine, get you used to seeing it, but it is no different than the inverse sine, equals pi over 2. Started with this, I know there's only going to be 1 answer. Okay.
1.
And again, this is going to be a number instead of an angle measure. I'm going to get rid of the inverse. So answer is a number, not an angle measure. Okay. And again, if I had the cosine of theta equal pi over 2, theta is an angle measure, and it's going to give me 2 answers. Okay, if I started with something different, like we have here, the inverse sine of x equals pi over 2. Okay, over here is, I'm only going to get one answer. Over here's my pi over 2. I'm going to send that over, and my answer is going to be a value, not a degree. So this guy, what is the sine of pi over 2? Sine of pi over 2. I'm going to do my way I figure them out. Sine.
Thing is one.
Positive 1, right. X equals positive 1. Okay, here's the sine curve. There's pi over 2. My y value is 1. Oh boy. Oh boy. Nobody ever said these are easy. These aren't easy. But the more practice you do, the better they get. So I'm going to ask you, just looking at this, what is this? My answer for just this right side is going to be an angle measure. Okay? The inverse sine. So really this, if I just looked at that right side and said this equals theta, that would give me the sine of theta equals 1/2. Everybody okay? I'm going to cover this side up. This is an angle measure. The inverse sine of a number equals the angle measure. The sine of an angle gives me a number. The sine
Pi
of
over
an
6.
I'm sorry?
It has a pi over 6.
I don't know. Might be. Might be. Sounds about right. Sounds about right. Okay. But I'm trying to get across the point. This is the inverse sine of a number equals an angle. A number will equal the sine of an angle. Just so we're not confusing. Well, okay, so good. I got that, and I know again. I have eraser boogies everywhere. So this guy is going to be an angle measure. And what if I said this angle measure? What if that would have been 1/3 instead of 1/2 or something crazy? So I'm going to say this is an angle. Okay, it's positive. So this whole theta equals that says, I have this angle measure, it's theta, and it's 1/2. And yes, I was told that if I throw a square root of 3 in here, that theta, that's 30 degrees. So the inverse cosine should equal 30 degrees. And if I now said, okay, send the sine over or the cosine over, I say x is the cosine of 30 degrees, x equals, well, I really didn't even need to go there because I already had this triangle drawn. Because now I want the cosine of this, which is the square root of 3/2. Point I'm trying to make was this was an angle measure. If I come down to, oh, not that one, this is an angle measure. I don't even think I like that last problem. So again, what if I would have said, okay, the inverse cosine or the cotangent, the inverse cotangent of x equals the inverse sine of 3/4. Similar problem. See if you can take care of that one. Similar to what we just did. See if you got it. All right, I know this is going to be an angle measure. It's like setting that equal to theta. And I'm saying, if I want to do something like that, and it's 3/4, here's my theta. This is 3, this is 4. That's really not a triangle, I know. But I can still work with it. I can still work with it. So if I'm taking a look at this, well, that's 16, that's 9. What's the adjacent side going to equal? Excuse me.
5.
Square root of 7.
Square root of 7. At 5 was tempting because I know there's Pythagorean triples 3, 4, 5. But remember, the hypotenuse always is the longest number. So if I went 3, 4, 5, I'd have 5 squared plus 3 squared. That doesn't equal 16. But yeah, I can absolutely see where that would pop up, that 5. Yep. But remember, the hypotenuse is the longest. Okay, so this is what I know about my theta. So the inverse cotangent is going to equal this theta. So now I'm going to say this. The cotangent of this theta is what my answer is. It's what x is. Well, the tangent would be 3 over the square root of 7. So the cotangent is going to be the reciprocal of that. If I took a quick look at this and said, the tangent of this theta is 3 over the square root of 7, but I know the cotangent's reciprocal. Yes, x equals square root of 7 over 3. So I didn't really need to know the angle measure. Over here, I knew it, which was great, but I didn't. I could have just looked at the triangle I drew from this angle measure. Huh, it's kind of neat. So if there's 2 inverses in the problem, I need to do something like that. Okay, I have another one. Solve for x. What do you think? Solve for x. This is what we did earlier. Nice quick practice. See what you got. Solve for x. We did one like this just a little while ago. Just the other night at the hometown football game. Cotangent of 3x. The inverse cotangent of 2y equals 3x. The inverse cotangent of 2y divided by 3 equals x. Feel good about that one? Maybe. Okay, gonna give you one last problem. Then I'm gonna see if there are any questions about chapters 5 and 6 to get ready for the test. From practice, I know I've done a couple of these now. This right side is going to equal an angle measure. Right side is an angle measure. Got it. Just did a couple of these. Get an answer, throw it up on the chat. Got one answer. Again, I know I started by saying this guy right here is equal to an angle measure. That right side is equal to an angle measure. I have another answer, another good guess. So let's see. I was drawing a triangle because I had the cosecant of 6/5 equaled theta. And so the cosecant of theta is 6/5, which I know the cosecant is the same as 1/sine of theta. So if I reciprocate this one, sine of theta equals 5/6. Is everybody okay with that? I took this, okay, good. I sent the cosecant over. I know the cosecant is the same as 1/sine. So if I flip this, I flip this. Now I draw this triangle to get that third measure. I think maybe I need it, maybe I don't. So here's theta. Here is 5/6. Okay, sine is, so there's a 5, there's a 6. I think this comes out to be the square root of 11. Following what we've done before. Okay, good, good, good. So now I come back over here and I go, oh, heck, I got it now because I want the sine of theta. Something that I already just found, and a couple of you had given me that answer of 5/6. Yay! You're learning, Patrick, Oloan, Chow, several of you gave me that answer. That's good. That's good. So many times through this course, DTT, draw the triangle. It's not sticking though, that DTT, but
I have a question.
yes.
What is the, like, what makes you the difference between drawing the triangle versus drawing the graph? Like, that confuses me.
You can do both. And there's one textbook that you will get that talks trig and only talks unit circle. And there's a textbook in trig that talks using the regular graphs. They're related. Sometimes they're a little confusing, but you can do it either way you want. For this guy, I'm putting him on a circle. I'm putting on in the 4 quadrants, so I can use that all spiders taste crunchy. And remember what we did, these graphs, when we took them and said, the hypotenuse is only ever going to be 1, then we started looking at values, and that's where we came up with our graphs, the sinusoidal graphs kind of deal. I don't know if did I answer your question, Kels? I guess so. You gave a thumbs up.
Yeah, I got it.
Okay, so we still have almost 25 minutes. And my question is, are there any problems from chapter 6 that you would like to see worked on? I'm going to stop the recording